welcome back. We spent quite a few hours learning the matrix operations and the properties. And now it's time for us to use the matrix to solve linear algebraic equations. You probably have learned how to solve equations in high school and by using the Gauss elimination method. But today, we just want to present to you more systematically, more efficiently, and a convenient way to solve it by manipulating the matrix. And we are also going to learn how to use MATLAB to solve the system equations. The first step we need to do is to write the equation into a standard way. That means you need to arrange every element in the right order. So let me just show you the example. Now you have these 3x3 equations. And you arrange all the constants on the right hand, and the first variable in the first column, second variable in the second column, the third for the third column. But you see you missed one element in the third equation. What you do is you fill in a 0 times x2. So when you write in this way, you can immediately translate into the coefficient matrix, which is the table of the coefficients, like 2, 6, 8, 4, 15, 19, 2, 0, 3. And we have similar exercise before. So the standard form, just the form to translate into matrix. Since it's a standard equation with n variables and n equations, so you will expect a square matrix n by n. If this square matrix have the inverse matrix, in other words, it's non-singular, to solve the equation is very much similar to solve the equation you know how to do it in elementary school. So if I give you 2x equals 3 to solve this equation, you just divide the 2 on both sides. You got it. If I give you the equation ax equal b, you say, all right, then you divide the a. Is this all right? Well, you say, probably. But what's wrong? Well, there's only one case it can be wrong. When this a equals 0, you cannot divide the 0. So be careful. If you have a parameter, make sure it's not 0. The same is true. If I have a matrix, we write the equation into ax equal b. An easy way, of course, we just multiply the inverse of a, and then you cancel out the a on both sides. Your solution is a inverse times b. Looks good? Looks as easy as we do it here in the elementary school. But we know not all matrices have the inverse. So that's what I need to remind you at the very beginning. But in case the inverse exists, all you need to do is multiply the inverse on both left and right, and you do two operations. Find the inverse either manually or most of the time by the MATLAB, Maple, and then multiply this inverse to the right hand. Another detail, because matrix is not commutative, if you multiply on the left hand, you always be consistent to multiply on the left hand. If you multiply on the right hand, it wouldn't make sense at all. Well, look at an example. Here is an equation, y equal ax. And if I want this, now here's the equation. I write the A into this matrix. So what I need to do is to try to solve this ax equals 0. Well, let me try to use the MATLAB. And the A, I write into the first row, semicolon, second row, third row, and then it will appear like this. And when you write the B, remember this little prime here is very important. Means you're going to write B as a column vector instead of a row. So this is a 3 by 1. Now the solution is the inverse A in MATLAB is this command, the inverse A, and multiply the column B. So you got your answer. Here you go. Your answer is 0, 0, 2. It is 2 lines of MATLAB codes, 3 lines. Input A, input B, that's how you specify the equation, and then 1 multiplication of the inverse. Back a little bit. If you think as a transformation, what it means to solve an equation? In the transformation, basically, you are looking for the inverse transformation of 0. You want to find which vector x will transform to the 0 vector from the transformation point of view. Well, looks pretty simple. Let's look at another example. Here you go. In this example, so I try to use the MATLAB to solve it. And we have 3 variables. And then the matrix is 2, 1, negative 1, 1, 2, 1, negative 1, 1, 2. So you do the same thing. Put the B first. Put the right side, which is 3, 0, 0 as a column here. And you multiply. So what's happening? Well, the MATLAB is complaining, give you nothing. NaN means no solution. But it is smart enough to warn you we have a trouble. To warn you have a trouble. The matrix is singular, means the inverse does not exist. So it's not always like this easy. We need a little more time to look at all different situations and the more systematically. Now let's try to do it by hand. Last time we learned the Gauss-Jordan algorithm. Gauss-Jordan algorithm have 3 rules. First rule, you're free to swap 2 rows or say 2 equations. The second rule, you can multiply a constant, not a 0, to each element of a row. of a row. The third, most frequently used, you can add a multiple for one row into another row, and the purpose most of the time we do this is to make some zeros in the column element.